I'm so pleased. Our next speaker is Tim Lasalle. Unfortunately, Peter Bick, our friend, due to an airline snafu, we had a couple speakers, including Gillian this morning, who aren't able to be with us in person. But hopefully most of you got to see Peter Bick's incredible sneak peek of his series, Roots So Deep, you can see the devil down there, about regenerative agriculture. It's a fantastic series, but it gives us more time with Tim Lasalle. Tim is co-director of the Center of Regenerative Agriculture and Resilient Systems at Chico State University. He was also head of the Rodale Institute and the Savory Center of Regenerative Agriculture. He worked with Howard Buffett on regenerative agriculture across Africa. He has an incredible career, and we get a full 20 minutes of his insights with us here today. Please join me in welcoming Tim Lasalle to the stage.
Thank you very much. It's indeed a pleasure to be able to share with you some thoughts, some experiences, and some future ideas about where we can go with regenerative agriculture. Actually, about 2007, I understood without it, we can't fix climate change. That hasn't yet been fully translated, and we need some more research to help prove it. But I'm going to give you some insights as to why that's real. But let me just begin by saying that one of the assumptions that we seem to make today is that, in fact, that we have an opportunity to just draw down, whoops, wrong way, and that we're going to fix this thing. But we're not without drawdown. We're actually going to have to pull it down, and I'll talk about that in a minute. What we've said is that we want to stay at 1.5 degrees warming. Well, we have enough parts per million in the atmosphere to far exceed that, and we're not stopping. We haven't decarbonized, and we have to decarbonize. What we actually have to move to is recarbonizing the soil, and I'll talk about that in a minute. But in Africa, where I lived for 4 years, Howard Buffett said, Tim, I got some of the best, worst soils for you to work with, and they were carbon poor, they were phosphorus short. And what we saw there was remarkable responses, which I'm not going to talk about too much today, but it was all due to biology and regenerative agriculture. But what I also experienced was Africa suffering climate change. Suffering climate change where farmers were committing suicide because they could no longer produce food for their families. Food security, really with regard to many of the poor in the world, is rural-based, where they are on land. Actually, the majority of the food insecure. And so what they need is to build those soils and build them for food security. So as we saw death and suffering, I would come back and talk in America and could never get a resonance with the fact that we're the ones putting the CO2 in the atmosphere. They're the ones dying. Now, as a Californian, we are suffering our worst drought since the year 800. We are now beginning the same process that we were foretold would happen. So let me just say that it seems to me, and the reason I'm leaving that picture up is in my little field at home, what cover crops can do, multi-species cover crops with regard to pulling carbon out of the atmosphere and building soil health. Do we know this? That half of our emissions are really have soil origins? We need to stop the fossil fuel, but we need to stop the loss from soils as well. In our legacy realms of what lives up there over 10,000 years, global warming actually started when we started farming. It changed the direction of a planetary cooling because we started to release more CO2 out of the soils. And did you even know this? I didn't. I recently saw a little bit of a study that actually nitrogen fertilizer is a bigger impact on emissions than our air flights. So I've stopped using fertilizer years ago so I can fly, but I don't know if you can. No, I'm kidding. We all need to be concerned about that question. As was mentioned last night by Carol King about deforestation, the transition of soil from one crop, forests, to farming is really problematic on soil loss of carbon. It is a big emitter, but tillage, disking, plowing is a huge soil carbon loss, and as we just mentioned, fertilizer. So this is where we also know that the way we've treated soil for 10,000 years is we do have 55 years of topsoil left. The trajectory of soil loss has not changed since the Dust Bowl. We continue to do the same thing. My field in Africa, up in the far left slide here, there was this field right next door that the weeds were growing like crazy, and I asked the farm manager if he'd just go and disc that. I was doing no-till, but would you disc that so those weed seeds don't come into my fields? One disking, one rainfall, and I felt terrible. Look at the erosion that happened. The next is just a picture in Burundi where we were doing some work with some ministers there, trying to get them to understand tillage is really problematic. 90% of Burundi is rural. They all farm, they all till. They've destroyed their forests. And I told them, what do you love about the Egyptians so much? And they looked at me and I said, well, you're giving them your most important resource, your topsoil. Every day it's washing down the Nile to the Aswan Dam. Here's what we're doing with our soils. We are degrading them rapidly. The soil temperature increases dramatically when it's bare. We're just in Blythe, California. It was 100 degrees. I had a bunch of Metropolitan Water District scientists out there. I took a soil thermometer and put it in the bare soil. It was 120 degrees. As mentioned last night by Peter and some people, when it reaches 115, you're killing the biology. Stepped them across to where we were doing some trials down there with some cover crops. That field was 80 degrees, 40 degrees difference. Here's a field that's like turning the heater on in 100 degrees and warming the planet. You're going to lose CO2, you're losing water, and you need fertilizer because you don't have biology there to produce the nutrients for the plants. You lose water holding capacity, you lose fertility, you lose soil structure. You can't actually get that water to percolate. You absolutely are going to lose yield and profit. So we need to regenerate. We need to rebuild what we've been destroying over this course of time. I hate to use this slide, but I'm going to use it just because it's a carbon cycle slide. There's an assumption in this slide that soil is respiring as much as it is pulling down. If that was actually fact, the Great Plains wouldn't exist. Actually, that started as rock, and now it's deep soils that we've been destroying. But there's been an accrual. And I want to disabuse ourselves of using the word sequestration, because in soils, sequestration means dead carbon. We are carbon units. Life is based on carbon. Life in the soil is based on carbon. And what we're trying to do is increase the life in the soil. And by increasing that life, we're taking it out of the atmosphere and putting that carbon, recarbonizing the soil. And that's why there's such hope for what could be done with soils and drawdown. We are tired of looking at the data and the science where they've been studying a broken soil system. Broken by the standpoint of saying they are looking at dead soils or bacterial dominant soils. And our farming practices have created those bacterial dominants. We're learning that we need to get to fungal dominant, and we're learning how we can do that and how nature will do that because it's self-organizing if we support her properly. So we're studying and engaging these outliers. And Gabe Brown's one. Amy mentioned him early on. Gabe Brown on the lower left. He's shown 11.6 tons of carbon per hectare accrued annually. Conventional science says you can do 1 ton. Conventional soil scientists attack Gabe Brown online. You can see the debates, and they're saying there's not enough nitrogen in his system to produce that much carbon. He's wrong. We know Gabe. We know he's not wrong. We've seen his soil tests. Russell Hedrick in North Carolina is getting 8.5 tons. He's using a bunch of fertilizer, not as much as the average farmer, but he's regenerating still the same. David Johnson, who was in the film last night, is a soil biologist in New Mexico. He was showing the same level that Gabe was. And we have a trial with Howard Buffett in Arizona where we're doing regenerative agriculture, simple shift in practices. He was already doing no-till, not tilling the soil. We brought in multi-species cover crops, and where Cindy Daly is up there on the left, we got 10.8 tons in 2 years. That was per hectare per year. All of a sudden, we're one of those outliers. What the implications of that are, I told Peter Bick just a few weeks ago, and he said, let's get on the phone. Because he can't quite get that in grasslands. It's important, the work he's doing, really crucial for the planet. And the farmland is 1.8 billion hectares. The grazing land is 3.5. Not all grazing land can do the maximum that Peter will later divulge. And not all farmland can do these levels, but a lot can. And here's why. So this is a root tip. And what is that root tip doing? And incidentally, root tips are stimulated to grow out of the root by biology. And if you're using fertilizer, you've gone on a chemical drug and the root hairs don't show up, the root tips don't show up. But this root tip, because it needs, in a non-fertilized environment, it needs a relationship with the biology, which we just said we need to be able to decarbonize or recarbonize the soils, is feeding the organisms with sugars and carbohydrates. The organisms, in exchange, bring, because it's a bartering system down there, I got to tell you, and they're bringing nutrients, minerals, et cetera, to what the plant needs, and water, actually, and water. So what you end up with is something like this. On the left is a picture of roots that have been fertilized, and the plant was tall and green, but you notice it's white roots, and on the red, we're sort of calling that, on the right, we're sort of calling that dreadlocks. That's what farmers that get it are saying, my roots have dreadlocks. When I first saw that in Africa, in my wife's garden, where she had put biodynamic compost in, and I pulled some weeds out, and it looked like this, I'd never seen it in my life. I go, is this a disease? It's not a disease, it's those exudates feeding all the biology, causing glues and stickiness. And so we know that's a living root system, rhizosphere, a life-based, carbon-rich environment that builds soil, that captures carbon, that creates diversity, biodiversity above ground and below ground, all at the same time. You know, the mycorrhizae fungi themselves can extend the root reach, not only in spaces that a root can never reach, but also can extend it up to 1,000 times if it's in a healthy system, which means it can go out and find water droplets, or boron, which is a very rare element that the plant asked for, and exchange for the sugars and the carbohydrates. It will bring drought resistance at greater levels than we understand. What we found in Arizona on Howard Buffett's farm is that they were slowly building carbon in their soils as we applied this trial with no-till and with multi-species cover crops. You see at the very end, within 2 years, it jumped that much. The farmer there said he could feel it when he walked out onto the field. It was tangible, it was softer, and we know the water could percolate faster. So here's our premise, and this is the only thing that seems valuable for me to work on, is to study these outliers, to develop a design and a project and an effort to validate the kinds of levels that conventional science doesn't understand yet. Because conventional science, West in 2002 in a meta-analysis, and Urs Niggli in Switzerland, who I visited his research center before, and Ratan Lal in Ohio, I visited his, who's known globally as a soil carbon expert, they report up to 1.5 tons of carbon per hectare per year. And so we are going to not pay attention to those broken soil systems, but to a regenerative, living, breathing soil system that can accrue at a much higher level with the 4 farmer averages that we're talking about, and we intend to be able to document. And why? We know we need drawdown. And what do we get from a technological mindset? We're going to build a plant in Iceland that can capture 4,000 metric tons per year of CO2 emissions. And at a cost, if we were to draw down back everything we're emitting, that would be $127 trillion. You know, if we decided to transition some sort of carbon payments or just some regenerative payments to farmers around the world, it would cost about 0.3% of that. And the side benefits would be more productive and resilient soil, means it could resist drought and it could resist flood, better water holding capacity, more nutrient-dense food because these organisms finding those minerals create a healthier plant, create healthier food. We can improve the water quality because we don't need the chemical parts to agriculture anymore. And in addition, we can reduce flooding, food security, and increase biodiversity dramatically. So there's all the side benefits to the climate benefits that this technology doesn't bring to us, and we're not sure why technologically, why we take CO2, which is a problem up here, and bury it in the rock, when if we take it from here photosynthetically and put it into life in the soil, we are reinvesting in the future, not just fixing a problem now. What I love is I talked to a farmer recently and he said, well, the thing about regenerative agriculture, it's a farmer-led movement, and I want to hold on to that. So yeah, I've been working on it for a couple of decades, but I love that they're taking claim and they're taking responsibility and they're teaching each other. We need a lot of other levers with regard to helping this transition because we're on such a short time frame to make this happen. And so we probably need government, we definitely need corporations, we definitely need the research institutions to get a new paradigm, a new understanding of what soil is about, and we need consumers to actually help push this. But all of these things occur. And of course, a lot of the reason we're here today for this conversation is the carbon dioxide drawdown. So this project that we have pulled together is starting now. It's already started in Blythe, California. This is a picture of Blythe. And they use the Colorado River water, which is, as you've been reading about the dam shrinkages of Lake Mead and all in that region, is really problematic. But in essence, they have been abusing the soil like most farmers. Metropolitan Water District has been paying them to set land aside and abuse the soil, and that's why we're trying to educate them to say, hey, let's think about using the soil differently. But we've started the project there, and we intend to move to 4 other farms across this country. So this project gets replicated in different environments, on different soils, by different farm managers, with conventional farming next to regenerative farming. So one of the things that we know in the farming, and why I asked Peter Bick last night to say, and why did you pick grazing? He got very attracted to it, and I think Alan Savory, who can be very engaging, kind of really enticed him to say this is the solution. But when I led the Savory Center, the board chair and myself kept saying, Alan, you have no data. I know you believe it, you're a genius, but you have no data. Richard Teague, who was on that film last night, was the first scientist to actually start to pull the data. But they're getting between 1 and 3 tons of carbon per hectare, and in the farmlands, if we can get 10 tons, or 7 tons, or 5 tons, we're going to make such a huge impact and difference in the world, and for the smallholder farmer in Africa, or the large-scale farmer here in the United States. So we are collaborating right now. We're out trying to raise the money like Peter. We got in the car and started the project before we had the money, and we're still going to have to get it funded. And so we're deeply working on that right now. My colleague Bryony Schwan is here as we're engaging that conversation more and more deeply. We know that government needs the data for policy shifts. We know corporations need the data from the standpoint of understanding what the potential is. And we know the carbon markets ought to need the data. The carbon markets are generally working on models now that don't understand this regenerative, biological, healthy soil process. And so we're pushing for conversations around outcome-based carbon markets only. No models, no practices. What is growing in that soil as far as carbon accrual and what is being lost? Make it real and incentivize heavy production of life in that soil, thus carbon. I just want to say that regenerative agriculture that really is focused on supporting the living soil provides the opportunity for a livable future. Without it, we actually don't have that. And Wendell Berry is very famous for saying, eating is an agricultural act. In today's world and today's realities, I want to amend Wendell's, if I may, humbly, to eating is a climate act performed 3 times a day. That is an activity we all do. That is an actionable item where we can have a sincere and actually deep effect. So feel free to connect with us. Dr. Cindy Daly is the director, a brilliant, holistic scientist who cares deeply about this process for the future of the world. And I have, somehow, miraculously, left myself 1 minute and 36 seconds left if there are questions or comments out there that I would love to respond to.
I have a question.
Please.
Interested in what you're doing in the Arizona Blythe area. What about Central California around
Yes. So I grew up outside of Hanford on a farm. I know about the area that you're talking about. We'll have a farm at the university, 800 acres in Chico. So I live in the Central Coast right now near San Luis Obispo. That whole area, we're engaging that question. We don't have funding to jump in there yet. What about it? Absolutely. Like Blythe, the response could be immediate. What that farmer showed, we're 18 months into another project with that farmer in Blythe. You could put a spade into that soil right now where the cover crops have been, and you'll come up with earthworms, I guarantee you. That farmer has not seen an earthworm in 30 years. Talk about bringing life. Nature just support her, and it responds just so rapidly. And we're seeing water percolation, where in the fallow field it takes 10 minutes to percolate an inch of water. In where we're starting to regenerate, it takes a minute and a half. That means that's not going to evaporate. That means it's going to go down into that system. There's pore spaces, there's organisms using it, moving it, et cetera.
And look at all the impact that you would have doing it right next to I-5 where everyone's traveling and everyone's using.
We'd love to. It's all about resources. It would be really crucial. Thank you for that question. Thank you for the opportunity to be with you. And we're here to engage any further conversations, questions, or thoughts you may have. Again, thanks.